Bilang 1, 2, 3.
1, 2, 3.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome to our Zoom meeting. First of all, let me introduce myself. My name is Muhammad Askar Abdullah. Here we're gonna discuss about Doppler effect. Doppler effect is something, some scientific that happen in this world. That's so interesting to discuss with, and I hope you guys enjoy our discussion about this. Yeah, let's start it. I gotta switch it to Rahima Nafiani as the moderator.
Okay, thank you very much, Aska. Hello, my name is Rahima. I'm here as the moderator of this meeting. I will just get to the point. So for the first, we are gonna have here the presenter to present explanation on what is the Doppler effects. After that, we are gonna have a Q&A session. So if anyone have a question, you can ask. Lastly, please be quiet when the presenter is explaining the material, and please keep the question until the Q&A session so it will not disturb the presenter while explaining. Okay, let's begin. I'm gonna switch to the presenter, Viero.
Thank you very much, Rahima. So I'm gonna start share screening here. Can you see my screen? Can you see my screen now? Okay. Okay. So we're here to discuss about the general understanding about Doppler effect, how it works, and a couple example. Doppler effect refers to the change in wave frequency during the relative motion between a wave source and its observer. Doppler effect happens when the object that's emitting wave is moving. So to make it simple, first let's talk about the object that produces a example of wave of sound. This way you can picture it easily. Okay, let's see. If we go to the next slide, we have the stationary object. So as we can see, we have the stationary object here. We can see that on the first one here, we have a stationary object that's producing a sound wave. Actually, I have the animation to what it actually visually look like here. Okay, so we can see that the sound wave it produced is stable on all direction. Okay, it means that you can hear that the sound is stable. The pitch is not rising nor dropping because the change in pitch depends on increase or decreasing in frequency. So because the object here is stationary, the frequency of the sound didn't change and the pitch will stay the same the whole time. However, if we look at the next slide, we have, we have now the moving object as our example in Doppler effect. If we look at that, the moving object now, the object as a sound source is moving, the wave frequency that the observers receive is going to differ depending on where the observer from the moving object. For example, here we have the sound source here, and this is the first observers, and this is the second one. Okay, now if we assume that the wave, sound wave, the sound that a moving object produced is heard different depending on where the observers. Sorry. This can also based on the movement of the observers, or both the observers and the object is moving either towards each other, further away each other, or chasing each other. So if the object is moving towards the observers will hear that the sound is actually higher than the actual sound of the object. And if the object is moving further away from the observers will hear that the sound the object produced is actually dropping lower than the actual sound of the object. So to make it more obvious, let's take a look at this video as I explained. And stop. So as we can see that, let's assume that this object is now moving to the right, to the first observers here in this point. So we can see that in the direction it moving, the wave front has bunched up, and behind it they spread out. This means if the observer is in front, as the observer is in this position, we will receive much higher frequency, and if the observer is behind the object, it will receive much lower frequency because the different wavelength of the frequency that it received. And that's basically how we tell if an object is moving towards or further away from us as the observers. For example, next slide here. Okay, now you're looking at an example of Doppler effect. It's called the Doppler ultrasonography. So it works by utilizing the Doppler effect. This type of ultrasonography can detect the direction of blood flow and also the relative velocity of the blood flow. It's common use in pregnancy check in medical. So Doppler ultrasonography can evaluate the health status of the features in the womb by assessing the flow of blood vessel in the brain and heart of the fetus that has been formed. The examination can also assess whether the fetus is getting oxygen and nutrition or not. On top of that, Doppler ultrasonography can also see abnormalities in the form of fetal growth disorders by seeing blood flow from the umbilical cord to the placenta and other fetal condition. Okay, that's it, all the information that I collect about Doppler effect. Thank you for listening. I'm very sorry if there's a misinfo. Wassalamualaikum warahmatullahi wabarakatuh. I'm going to switch this to the moderator back. Rahima?
Okay, thank you very much, Vero. So next we are gonna have a Q&A session. Does anyone have a question? Okay, from Najwa Naila. Najwa Naila, I want to ask if sound wave the frequency equal to pitch that what about okay.
Okay.
What about
I'm gonna take over for now. Okay. Naila, okay. If sound wave frequency equal to pitch, then what about light? So, as we know that sound can crawl through space, so instead, scientists and astronomers use electromagnetic waves such as light to examine space objects hundreds of thousands light years away. Frequency for light wave is actually electromagnetic spectrum, or we actually call it spectrum color 2. So on the table of electromagnetic wave, we can identify visible light more easily than other EM wave because we can actually see it with our naked eye. So that's why to measure if an object is moving towards or further away from us as the observers is to measure the change in spectrum. Higher frequency leads to much bluer color. This happens when an object is moving towards us. It's if you ever heard of it, it's also called blue shift. And conversely, a lower frequency leads to much redder color. This happens when an object is moving further away from us. It's also called the red shift. Okay, that's the answer that I can present. Any more question?
Does anyone have any more question? If not, we are gonna end this meeting.
Okay, it seems like there are no.
Okay, that's it for this meeting. Thank you for joining us. Assalamualaikum warahmatullahi wabarakatuh. I'm gonna switch back to the host Aska.
Yeah, guys, so that's it for today. I hope you enjoy our discussion about Doppler effect, and I hope you can find it interesting to learn too. And I hope we can meet next time too, wherever it is, and we can brainstorm with you guys. Yeah, thank you for all your attention. Wassalamualaikum warahmatullahi wabarakatuh.